Okay, for our next little part, we're going to use one of my personal experiences with density and how it applied to my world. Now, this is just one scenario that happened in many different times when density was used in my life. Now, I'm going to have to move you guys around for this because you need to see a full view of things. So don't be afraid if you're moving. Alright, so here is my trusty area of density experiments in my lovely basement. Pretty cool down here. We got it furnished, so, awesome. Alright, I am going to now explain to you what happened the day of September 19th. This time was, in that little time span of rainy week, and it was really very rainy during that time of the week. So I was walking every single day from school back to my house, and I would walk and I'd see it'd be raining and it would just pour and water puddles everywhere. So at this time, we were kind of just starting to discover density, not only in science class, but in the outside world with myself. So I really didn't know density before this science course, but I was kind of understanding it before we started learning about it. What I did was I found this tennis ball that I kept because I wanted to do it for this project. My portfolio. I took this tennis ball and I threw it in a puddle. What I noticed was that the tennis ball floated in the puddle. So I thought, that's super cool. I didn't know that. I thought the tennis ball would sink. But I realized that the plate, or also known as the little puddle of water, was more dense than the tennis ball. Because the tennis ball, it was floating. The tennis ball had less density than the water, and that's why it was floating. So this was a very small amount of water, and it was just a tennis ball. But then I kind of had a little idea. I told myself, what if I went to the pond and threw it into the pond? Would I still get that? What's that noise? That was weird. Oh, I was gonna say, what would that do to the water? Would the tennis ball still float in the water, even though it has a larger amount of volume, or would it just keep floating? So I told myself, you know what? I think the tennis ball is gonna float because it's definitely weighing much lighter than that huge amount of water. But weight has nothing to do with density. So, by stating this, I was incorrect. At the same time, I was correct because I said that it was going to float. So, this will be the representation of the pond. And you saw that big splash. And the tennis ball is still floating. Now, don't worry, I don't wash my dishes in this. We use a different sink. But I realized that the water will always have the exact same amount of density no matter how much weight or volume there is. So I was like, wow, I wonder if that's true for every single element / compound. I was correct, because when I took the tennis ball and I put it in a different compound, it was a liquid and it still floated. It was just, it was water with, I forget what I put in it, but it still floated in that water because it has less density than the compound I put it in. So, even though something may be a larger amount, it's always going to have the exact same amount of density, and that's how it applied to me one day in my life. Another time I could think of would be when I put ice in my water. The ice that's in my water will always float because it has less density than water. So, that is my presentation / concept thing on density, and I hope you enjoyed it. So, yeah.